All right, so this is the presentation from Uganda. We, as you all know, are a new team joining the SickleInAfrica family. And therefore the presentation is going to be talking about our thoughts, because we're only in the beginning stages. We actually haven't started. And so that is what our talk is going to be themed around. Very specifically for the database side, our aim or our objective is really to develop a centralized electronic patient-consented sickle cell hemoglobinopathy registry, and that means that we intend for it to include both epidemiological and clinical data, and where possible, if possible, genetic data as well. So we also hope that we will grow initial information that we might have right now, sickle cell data that is loaded in our existing databases, that will be loaded into this one. And of course, the aim will be to align it, both to grow it, but also to align it with what is already present, what you guys already have. And in doing so, we have every intention to also overlay it with extra analytical pipelines. And that means for local analysis that might be relevant. And so our registry will have a script coding, but then also software component to address the third sub-aim. And of course, all this work, as my colleagues before have mentioned from the other countries, is that it involves transforming, of course, paper records. We do have some of those now. We hope to also translate case report forms into digital forms. Again, like other individuals mentioned, we intend to enable electronic data capture. And that can be both on phones and tablets, but also other gadgets that might be relevant. We actually want in the phone area to even enable SSD, but also even audio. There are some capabilities we're developing around that here. Of course, we will be paying attention to ontologies that you have already developed within the continent-wide registry, and where applicable, our own local ontologies. Of course, this is going to be REDCap-based database, although we will also complement it with relational database, again, for our local needs, unique needs, and processing fluency that might be required locally. Of course, there will be a connection between this database and the continent-wide one. In fact, as has been mentioned before, a lot of the logs will be going straight to the continent-wide database, because it's that branch is fairly well developed already. Consent is an important thing which we hope to track for every individual data item and entry, and we want to automate that tracking so that it can easily be tracked to enable processing or rights assignments. And training is going to be a constant part of this, and we imagine this workshop that we're having now is part of training for us, hearing what others have to say and what has already been developed. This is the team, not the whole team for the project, but mostly around the registry. Professor Sarah is our PI, and we have a coordinator, Ruth, and Dale, who I think is also on the call, and myself in the middle. And we have the technical colleagues we'll be working with. Mike Nsubuga is a master's bioinformatics student with a computing background. Grace Kebirunji, she's a master's in microbiology, but also has a lot of training in coordination and project management. We'll be working with Henry Mtekeki, who is a developer, because we intend to have apps overlaid over the database, as you'll see later. Rogers is a systems administrator, because we have an established IT environment and high performance computing environment, which you'll also see later. And Frederick will be our on and off as need arises. Bioinformatician. He's also a completing master's student. I am myself a PhD in bioinformatics. And so this is how we intend to organize the team for the registry. The PI leadership and the project leadership at the center will be informing all the activities within the registry and directing them. And the registry itself is, of course, going to be led by the registry co-investigator, who will be working with a coordinator and a lead developer. And of course, that involves both REDCap and relational database developer. This is mostly for the infrastructure. The systems admin handles the infrastructure here. As I said, this will help most of the bioinformatics components, especially if we end up having any genetics data, but also script development for analytical data analysis. And of course, for the apps, we will be needing a software developer. But the whole idea is that, of course, we intend to have 3 what we call clinical sites, the major one being Lago Hospital in central Uganda, and we'll also be having some in eastern Uganda, in the cities of Jjingo and Bale, and northern Uganda in the city of Lira. These are also high prevalence sickle cell regions of our country, and so we want to capture them. And of course, we're going to be having data clerks at each of those sites to help with the data capture. And they're going to be trained on the apps that we'll be developing for that. And the data will be coming in to this level for the database development, as you see in the data architecture that's coming up. And of course, there is a lot of crosstalk between the PI leadership and the clinical sites. They lead that relationship of establishing the clinical sites and monitoring and facilitating them in every way that they require to be able to capture the information that is needed. Architecturally, this is what our registry is going to look like. I just talked about the PI and the science leads leading the whole project. But as you can see on the top left is the Sparkle Coordinating Center, or the continent-wide database that you already have in place. And the idea is, of course, the science leadership of the project defines the questions which inform which data is collected from the sites, and that is filtered automatically to the REDCap database, which connects straight to the continent-wide database. And then locally, we're able to overlay different forms of analysis from a genetic and statistical perspective, data science perspective, to filter out specific outputs. We hope that this will include analytical reports, on-demand analytical reports, critical variables that we might be able to identify through the data science. Of course, genetic variants, if we end up having genetic data, abstracting different components of the value chain of sickle cell in the country, analytical pipelines, algorithms, optimized ontologies, which can inform other databases, and any other linkages that might be important. And of course, this is just example outputs that we hope will come out. I've been listening to some of their presentations, and clearly there are other important outputs that will be able to be derived from this. So architecturally, this is how we hope to be set up. And that means from a data flow perspective, that means how data hopes how we hope for the data to be handled and processed. Of course, it starts at the high level questions that are set by both the continent-wide sickle cell community and the scientific leadership of the project here. And those inform the data elements. A lot of them have been developed, but we'll be looking carefully to see there's any additional data elements that need to be defined based on our specific context. And those are also end up informing how the databases, both the REDCap and the measure databases, are configured, which variables are captured, and how the relations are defined within the databases. And of course, out of those, analysis happens, and that analysis is disseminated through apps as an example, but we hope to have several forms of dissemination. And this both goes back here. There should be an arrow here where it goes back to inform the clinical sites, but that can also happen through the scientific leadership. Some of these specific activities that constitute some of this data flow have already been mentioned before. In terms of infrastructure, and again, we've been hearing some of our colleagues share, we're perhaps a little bit lucky that this is something that formed when we had already been working on the infrastructure side for other projects outside of this sickle cell project. This is infrastructure we're working on with NIH. This is only a snapshot, but very specifically, I want to mention that and you might have experienced it already, in our context here in Africa, power can be quite unstable sometimes. And so we're taking very intentional steps to address that. What you see here on the left are high-level lithium-ion batteries to support power instability. That doesn't mean that power goes off, but it means that power fluctuates. And you need kind of a stopgap battery power to cover up the fluctuation so that you maintain a constant thing. And what you have here is not clear, actually inverters, which have also just been installed over the last 3 months to capture power, battery power, and convert it quickly into electric power for the servers. Small picture here, but the capacity is quite significant. We have up to 720 cores and 4.4 terabytes of RAM. And this is supporting a lot of research, even outside of what we're doing here in sickle cell. And that means that it has already developed some capacity to support what we're doing. Right now, the storage is at 500, but the capacity, we have 1,000, which is not yet activated. So as need arises, this can be ramped up to 1.5 petabytes, 1.5 petabytes. And this is very key. We're seeing this very clear in our ecosystem, how compute is becoming a super important part of biomedical research. So these are the backups we've talked about. We do have an NREN connection. This is a worldwide internet support and local research support network with that kind of connectivity. Of course, we also have up to 24 working stations that are optimized for energy savings and superior audiovisual experience. Some of it is probably visible here. This is mostly for if we end up having to train anybody locally and or to have people do some local analysis. These workstations are plugged into the HPC, which you've seen here, to support the same component of the value chain of sickle cell in this case. So data quality is something that we're paying attention to. And my colleague is going to quickly talk about it. So
under data quality, these are some of the techniques on how we envision to carry it out. And that ranges from the data discovery, where we have
okay, good. Our connection doesn't seem to have worked very well here. So what Mike was going through, and we apologize for that, is that we hope to follow data quality really in the same way that some of our colleagues have mentioned before, starting with data discovery and going on to proper data profiling, following all the rules as stipulated, both ethical and technical rules, and also translating ethical rules everywhere possible into technical applications or technical renditions of those rules. And that informs, of course, data access, data processing, data monitoring, data remediation, and data quality reporting. The idea really here in this slide, if you're to capture any idea, is that every data requirement in terms of quality and ethical clearance, we hope to be able to translate it into technical specifications that can automate that requirement. We do have backups, both on-site and off-site backups. So we have server snapshots. So we do capture snapshots, cross-sectional snapshots of our servers every day. That means every data that's there every day, we capture it and then back it up. Both local, because we do have some redundancy in the storage, memory storage, but then also using offsite tapes to get this kind of backup for the data. So far, like I said, we're just at the beginning process, having joined the network just this year. Our sort of issue that we've just cleared has been REC. We've had spent a couple of months, as you all know, trying to get the REC and IRB clearances through the ethical review boards. We have now got feedback about that. And apologize, I think that's not supposed to be pending. We've got feedback for that, so that's okay. We now need to get administrative clearances from the clinical sites. So the REC clearance has been in the central. The clinical sites, what we showed before, we need clearances from there too, and that is work in progress. And once we have those two, the National Council will also have to give us clearance, but it tends to be easier once you have the first two cleared. So we are also having a lot of meetings around the SOPs that you mentioned, or the protocols, the standard protocols, to make sure that they align well, and also we define what is required in our ecosystem. And of course, this is the support that we're getting for this, and the funders and sponsors for us are the National Heart and Lung and Blood Institute of the NIH, of course, SPACO, SickleInAfrica Consortium, and Makerere University. Thank you.